Good morning, everyone. Yeah, we start with some delay because of the fire alarm. Perhaps the students who are online, they do not know why we are starting somehow late, but yeah, it is what it is. Yeah, we will perhaps shorten a bit our breaks. Instead of having 15 minutes, we will have just 10 minutes break so that we can compensate the delay we started with because of the fire alarm. Good. Yeah, how are you feeling today? Yeah, very good. Very good. Yeah, the summertime somehow did not influence your, sleeping rhythm, etc. Because yeah, one hour actually has a bit of influence. So now it's actually 7:30, 7:45. But since you feel good, this is really nice. Okay, so what we have done last time we looked at the details of BPMN, Business Process Modeling Notation. And we tried to discuss the most important symbols, let's say, that are used in BPMN. The gateways, the activities, the sequence flows, the events, starting and ending events. And as I told you, we did not go really into depth into BPMN. If you would like to do so, of course, we have a lot of literature on that. But we have done is sufficient for our course on process innovation and supply chain management, right? And supply chain innovation. Now, yeah, what we have discussed last time also at the end of the lecture was the different types of activities. We have said that there are value-adding activities, right? So customers are paying for the value-adding activities. We have to ask ourselves, if we get that activity out, would the customer be influenced? Would the customer perhaps be negatively affected by the elimination of that activity? So is very, very important. For example, confirmation of delivery date and delivery of products. This is what the customers are paying for. Then we have the business value-adding activities. We should minimize them. So these are activities that are from a business point of view. For example, if we would like to capture customer satisfaction, or we would like to achieve compliance, these are important from a business perspective, but customers actually do not pay for. These are activities that companies have to do. So will the business suffer in the long term if we don't do them? Do they reduce the risk of business losses? And then we have the non-value adding activities that have to be eliminated altogether. Why? Because they are waste. We are doing them, although they are not necessary from a business perspective, and also customers are not willing to pay for it. Therefore, they have to be eliminated. We have handovers, for example, waiting times, delays, etc. These are not the activities that companies should strive for and should try to implement. Rather, the company has to completely eliminate them. Why are we doing this? Why are we classifying activities? For one single reason, because we would like to see what improvement possibilities we have, right? So if we can categorize the activities in value-adding, business value-adding, and non-value-adding activities, at least we can start with non-value-adding activities by eliminating them, right? And this will lead to a new process, to a new supply chain innovation or supply chain process, which we can consider, even if it is just incremental, a small improvement, but it is an innovation, right? So, and therefore, process mapping in the area of supply chain is very important. Mapping, it means we would like to draw all of our processes, how they function, the activities, the sequence flows, the events, etc. And then we can do this kind of work by classifying the activities into 3 categories. Now, we use this exercise in order to understand which activities are value-adding, business value-adding, and non-value-adding. And yeah, it is the equipment rental process. So just to remind you a bit, so we have the site engineer who is submitting an equipment request. So the site engineer is the engineer who is working in a construction company on the construction site and has a request for a certain equipment. This equipment has to be rented. The clerk, who is the one looking for appropriate equipment, and the clerk selects an suitable equipment, then check the availability with the supplier, and if it is not available, then the clerk will look again for another supplier that can provide that equipment until it is found. And then once it is found, then there is a request going to the works engineer. He is the manager, let's say, the responsible manager, who will be approving or not this rental request. If it is not approved, then the request will be rejected. If it is approved, then there will be a purchasing order or rental order created and then submitted to the supplier, who will then deliver the equipment to the constructions. Now, what does the activity submit equipment rental request consist of? It consists of fill request and send request to clerk. So we have said that fill request is important. So we have to capture the main important requirements by the site engineer for the equipment. So fill request is value adding, and then send request, since it is a handover, so we are just submitting a document from one lane, so from one resource, which is the site engineer here, to another one, which is the clerk, then it is non-value adding. So handovers are always non-value adding. If we look further, so what does the clerk do? Once the clerk receives that document from the site engineer with the requirements, perhaps for the construction equipment, the first thing that the clerk does is to open the document and to read the document. So opening and reading, actually, yeah, they are not necessary. So actually, it could have been automated, right? So, and select a suitable equipment is an important task. So why it is value adding should be value adding, so the selection of suitable equipment, because the site engineer communicates requirements and the clerk has to find a suitable equipment to these requirements, right? So if the equipment features are corresponding to the requirements of the site engineer, then that equipment will be useful on the construction site. Okay, so open and read from customer point of view, nothing value adding, and select suitable equipment, at least for the first time, right? For the first time is value adding, and then if we do it again and again, so if we do an activity again and again, this is actually not good. So, and therefore we have open and read is non value adding, and then the select suitable equipment is value added, at least, not at least for the first time. Now, let's look at the other activities. Check equipment availability, record recommended equipment, and forward request to works engineering. Check equipment availability. So it's important, right, for the first time to look whether the equipment is available with the supplier. Because if it is available, we will be perhaps renting it and sending it to the to our construction site. Now, the check equipment availability is value adding. Then record the recommended equipment. Recording, it is important from the business point of view, but not adding value. So it's for a business, from a business perspective, I have to capture, let's say, that equipment I found with the supplier in order later on to place the order with the supplier, and forwarding request to works engineer. As I told you, handovers are always non-value adding, and this will result here. So check equipment variability is value adding, record recommended equipment is business value adding, and forward request to works engineer is non-value adding. Now, the document or the request or rental request is now arrived at the works engineer, the responsible manager. And the responsible manager will do some tasks in order to approve or not. So the responsible manager will open. So opening is not value adding, but examining. Examining. So there is the task of examining whether we really need that equipment on the site. Because if the works engineer says, no, we can do it differently, the equipment is not required, then the equipment will not be rented. So from a business, okay, here open, perhaps not, but examine is definitely important. So, and therefore it is open, this is important from a business perspective. Communicate issues. If there are issues, by the way, if we identify problems, these are always important because problems is what an organization, what the business can learn from, and therefore, communicate issues. They are rather business value adding, right? So we have to communicate these issues. We have to say why perhaps it has not been approved, and therefore, from a business perspective is important. At least the site engineer has to know why it has not been approved. So this is from a business perspective important. So if you, let's say you are applying for a business trip and then you don't get it approved, you would like to know why it hasn't been approved. So from a business perspective, it's important. Otherwise, perhaps you feel demotivated, you will not be wanting to work, etc., because your trip hasn't been approved. Okay, then from a business perspective, it's therefore relevant. And then forward request back to clerk. Forwarding, again, not what we are looking for, so it's non-value added. We have here again the results, more or less, and then at the end, we have to produce the PO and submit the PO to a supplier, right? So again, here we do the same reasoning. So from a business perspective, of course, this purchasing order, we have to produce it. Yeah, it's important. But the submission, so this is business value adding, but the submission of the PO to the supplier is value adding. Okay. Yeah, I know sometimes it could be difficult to identify, but or to make the difference between value adding for the customers and business value adding. But in order to understand it and to identify it very well, you have always to ask the questions that we dealt with last time. Okay, does the customer pay for it? Yes or no? If we eliminate it, does the customer feel it, right? That something has been reduced in the service or in the value creation that the supplier is used to provide. So this is the most important questions you have to ask every time. And then for the business value adding, also to ask the questions that we dealt with just at the beginning of today's lecture. Okay, any question on this? Seems clear, right? And this is also what I would recommend to you. If you do a process mapping, the first thing that you have to think about is how you can categorize the processes or the activities into these categories to generate some improvements. Okay, so here this is nothing less than a recapitulation of all of the types of, or the categories of the processes that we identified. Good. Another thing that we can do is that we can look at the sources of waste in the supply chain. And this is extremely important. So we have to see where the waste is coming from. And there are 7 sources of waste that, this is from lean management, right? perhaps those who have done lean management, they know. Yeah, lean management provides us a lot of indications, a lot of hints how to improve processes, and this is the same old supply chains. So we have three categories of waste. So we have move, and in move we have transportation and motion. What's the difference between transportation and motion? What's the difference between transportation and motion? So transportation is always when we are moving something, when we are moving an object, where we are sending a document, where we are moving goods inside the warehouse, inside the production shop floor. So we are moving something, moving a good, let's say, or moving an object. Motion is when people themselves move. So it is people's movements, right? So if you have people moving a lot, let's say in a warehouse or on the shop floor, it may be good from a health perspective because they are moving often, they are doing some sports, but you don't have people in the shop floor, you are not paying them for doing sports. You would like actually to optimize their movements, right? Inside the organization, so that they can do the activities very, very fast and efficient. Yeah, let's imagine that you are improving the processes of the supply chain in hospitals, right? Hospitals have supply chains, although they are service organizations. You don't want to have doctors running long distances because this could be a very bad thing, right? So people needing very quick help, fast help, and then you have doctors having to do long distances in order to reach their patients. So very, very important also to optimize the motion here and to reduce the distances that are walked by people, right? Is it clear, right? Then we have hold. Hold, it could be inventory. Yeah, we know. So it could be an inventory of documents, right? So a lot, let's say, of insurance claims to be worked on, or it could be a lot of customer orders that you have to deal with at the beginning of the week. So this is inventory. And waiting is, or it could be goods, obviously, that are waiting for the next process step in production, or it could be waiting, right? Waiting is just the goods are idle. They are waiting for the next process step, or the process of service process is not coming forward because the next processing station, let's say, the processing operator is just busy with other things or just idle for some reason. So waiting is also something that we have to reduce. Right? Then we have overdoing. So it could be defects. So defects when we have quality problems. So defects is always when you have rework, right? So this is, you need to do some rework. So you have a defect, and then in order to make it better, to improve that good or to improve something, you have to rework it, right? So it's like when you have an activity here. Right? So you do some activity, and then you are not happy with the output of the activity. So they see the input, then you do the activity, you are not happy, you have to do some rework. So it has to come back in order to do work, in order to fix the quality problem. Okay? So overprocessing is that when we do something and then we complete it just to notice afterwards that it was not required at all. For example, perfections. Let's say it's perhaps a very simple example. If you go to a fast food and you have the restaurant, this is also a process, right? Process, and the restaurant is a service company. Fast food restaurant giving a lot of attention to the decoration of the dish. Do you expect decoration of the dish when you go to a fast food? So obviously this is an over-processing. You see what they are doing? So they are increasing the price just for us to get some decoration is not needed. Right? So over-processing is that over-perfection. You are doing things only to notice later on that you don't need them. So yeah, this is and overproduction. What does it mean, overproduction? You're doing more than you need. So you are doing more, let's say, components, or you're producing more products than it is actually demanded by customers. So everything I see here is bad, right? We would like at the end to have demand is equal to supply, and every overproduction is actually not productive from a supply chain, from a production perspective. Good. So we will try to look at our process, the same one, from a waste point of view. So here, the same process. So I kept the same process in order really to understand everything in a good way, not by changing the process every time. Then I have to explain the process once again. So we have the same process. We go through many tools and many ideas, let's say, by using the same one. Good. Yeah, where do we have waste here? Sorry? The handovers, very good. So we have a lot of handovers. Could you perhaps explain where we have handovers? Okay, so whenever we have a transition, let's say, or a sequence flow from one resource, from one lane to another, right? There is from one lane to another, there is a handover. Okay, and here there is a waste. Where do we see other waste? You have to develop that skill also when you look at certain BPMN processes, try to find where things may go wrong. So we see this pattern, right? We see this here, also here, right? We see it. We see it when the clerk opens and reads the requirements from the site engineer, and then looks whether there is a suitable equipment with a supplier. If he or she doesn't find, she has to go through or many times through the same process. So it looks like a loop here that is very similar to defects, right? Right? This is similar to defects. And defects is a quality problem. Yeah, it's a quality problem. Yeah, it could be understood also as a quality problem. Okay, do you see another source of waste here? Look at the last step. Look at the last step. What the works engineer do. So the site engineer requires an equipment, And then the clerk finds an equipment and then sends everything for approval to the works engineer. But if the works engineer does not approve, what does it mean? It means that all we have done before, the searching, the work that has been done before is not necessary at all. So we are doing a lot of work just to notice later on that we doesn't need it, because just the works engineer rejected the request. And this is exactly this last part in the diagram. So the rejection. So what does it mean when we do many activities just to notice that later on they are not required? This is the typical example exactly for overprocessing. Okay. So once we identify the sources of waste, you see, now we are seeing our process differently. So I know it when you see the process at the very beginning without using these tools for the examination of the process. The process may seem really natural. Okay, there is someone request, and there is somebody else in the organization looking for possibilities, and then there is somebody who is. So it seems very, very natural. But at the moment where we include all of these concepts, we see that our process has many issues, has many problems, and there is a lot of opportunity for improvement. Okay, so here you have the all of the problems that we identified, the defect and the overprocessing. Here it is, the details. But perhaps there are things that we may not see directly when we deal with the map of the process, but there are things perhaps that we could identify when we deal with the process in depth, when we know what exactly happens. Okay, so for the transportation, the handovers, I don't deal with them because this is very clear. Now, inventory. Inventory emerges in this process when equipment is kept longer than needed. Imagine that the site engineer just extends the period of using the equipment, but actually he or she doesn't use it effectively or does not use it at all. So that you are accumulating inventory, perhaps it happens also, just to be sure, or that the site engineer thought that it will be needed, and at the end they notice that perhaps some works have to be done before it is needed, and therefore it has to be returned and come back. So in any case, it has been extended for a certain time, but it has not been used at all during that extension. So it means here that we are accumulating inventory of equipment, although it is not required at all. So this is something that we don't want to have, we would like to avoid, right? But you don't see it directly when you examine the map, you examine the process. Then waiting also you may perhaps just think of it, but you don't see it directly in the process. It is waiting for the availability of works engineer to approve. What does it mean? The works engineer, as I told you, it is a responsible manager. Perhaps he is very, very busy. He's on a business travel, and he could not look or examine the documents for the equipment request that he has, and therefore things are just accumulating on in the office, and then he's out of office, and therefore, okay, we have to wait until he or she comes back. By the way, this happens in organizations all the time. Yeah, let's say you are wanting to go for a business travel. Yeah, and it happens a lot also in organizations. But before starting your business travel, of course, you need approvals. You cannot just go there, yeah, because there is insurance, the organization has to know, the mission, let's say, goals have to be very clear. And there has been someone in the organization who is generally your manager that has to approve the business plan. Because there's also a budget that is required, there's hotel, there's travels, there's also per diem, many costs that will be included in the business travel. And there's somebody that has to say yes. And if that person is not there, for some reason, then perhaps you do not get your business travel approved. And therefore very important, and this is perhaps from my experience, if you would like to go for a business trip, try to provide a request or to insert a request very early so that your manager knows when you go and then has time in order to approve your business travel. Good. So this is waiting for availability. This is the same thing to approve. As I told you, you can understand that these problems are out there only if you work perhaps in the organization. You may not be able to see them directly from the process map. Defects, selected equipment and supplier not available, so you have to look at alternative equipment. Then incorrect equipment delivered and returned to supplier. It may happen, right? So we are living not in an ideal world, that the clerk may not have done the work correctly. So identify an equipment that does not match the features requested by the engineer, by the site engineer. Perhaps the supplier has delivered the wrong one, although the clerk has identified the good one or the appropriate one, so many defects could happen. Then we have over-processing. Clerk finds available equipment and rental request is rejected by works engineer, or rental request being approved and then cancelled by site engineer because no longer needed. It could also happen, right? So the works engineer says, yes, it's, yeah, we need that equipment. So I'm agreeing with the site engineer, but the site engineer says, okay, yeah, it's not longer needed. So there is delivery and then it's not requested. This could happen. And this is over-processing. So all what you have done was not necessary. So there have been a lot of people involved, a lot of departments perhaps involved, money that has been spent on this, only to just see at the end that it is not required at all. And then we have overproduction, equipment being rented. So it has been rented and delivered. The site engineer did not cancel anything, said, okay. Perhaps the site engineer fears that he or she says, okay, it is not cancelled. So what they are doing is that they're saying, okay, we need it. It is put for 4 or 5 days, let's say on the construction site, and then it is not used and then brought back to the supplier. So this is an example of overproduction. Right? We are just accumulating inventory for nothing. Inventory of equipment in this case. Make sense? Yeah, you see, for a simple process, how many things may go wrong. Yes, please.
Especially for the inventory, that something we call inventory is what occupies space.
Yeah, so it is an inventory. Inventory is everything that you are putting on stock. Right? And on stock, or it could be also a work in process inventory, right? So these are the two things. So you may have goods that you sell at the end, but you may have also documents, and you may have also, let's say, components for maintenance. So these are also components for repair, tools for repair, equipment that you need for doing the construction task. So everything that is like this is an inventory. Is of the inventory.
You said that documents could also be issues.
Yes.
This got into my mind. Is there a concept of digital inventory? You also have like documents. a lot of documents piled up in our laptops.
Yeah, exactly. So it could be in paper or it could be digital, so it doesn't matter a lot. Yeah. Good. Okay, what we will do now, so we will do a flow analysis. So we would like to make some calculations, some simple calculations with respect to cycle times, and then how to uh, discover how long the process takes in order to be completed. So yeah, we would like also to understand the performance. With respect, we would like to have high performance of our processes, and therefore we can do some calculations. Right. So yeah, we have this process. So we will do the flow analysis of cycle time in the service supply chain and credit assurance. So you would like to get a credit from the bank, and this is the process that your application has to go through in order to get the loan at the end, or the credit. So you put an application for a loan. So what the organization is doing is that, or the bank is doing, is to check completeness, so that all of the documents are completed. And if a document is missing, then there will be a process in order to correct it. So perhaps the clerk or the operator in the bank will call you and will tell you, please submit this and that document. And believe me, this happens many, many times. So you put your application, you submit your application, and then all of a sudden you get the first call. Yeah, some more documents have to be sent. Then you think you have submitted everything. Now, no, you have to provide other documents until at some point in time, okay, yeah, they ask for everything, and then, yeah, it has been completed. So this is the application, right? Once the application is completed, now there is a process that is done by the operators in the bank. So first is check credit history. Check credit history. For example, if you have had some credits in the past and you have been repaying or paying back your credits very well, so there is no problem. Okay, so this is a positive point that it's in your favor. And then check income sources. So this has to be done in parallel. Check income sources in the sense, yeah, how is your income? What about your contracts with the companies? Are your incomes high enough in order to pay back the credit? How long are you employed in the company, etc.? Good. Now, once done, the application is assessed. So it depends, of course. Perhaps there are some very clear cases, but there are cases where it is clear, okay, clear and positive or negative, and there are cases which are not very clear, and then therefore the application has to be assessed. And yeah, this process needs 3 days, and then yeah, you have the duration of the processes, right, in blue, and then you make a credit, or the bank is making a credit offer, or is notified rejection, saying no, you will not get the credit. And at the end is the application is, of course, the customer is informed, and the application is then processed, is done, completed. And we would like to identify the cycle time. How long does the bank need in order to finish this process? Make sense? Good. Now, let's look at it part by part in order to understand how we calculate this. Okay, so we start with a very simple part of the process. So we have a sequence. What's the average cycle time here? So A has a duration of 10 and B has a duration of 20. Very simple. 30. 10 plus 20. Now, here, Yeah, we have alternative paths. So here we have a join gateway, right? A join gateway. Sorry, no, it isn't. Yeah, it is. Sorry, it is an XOR. I have to say XOR, mix or here split. So it means that we have, after having completed 10, we can either go to B or we go to C. So either or, we cannot go to both. So we have only one single token coming out of the XOR gateway going through B or going through C. How do we calculate this? Actually, not to calculate this, we need more information. We need probabilities about how likely it is that we go through B and how likely it is that we go through C. And once we have the probabilities, it would be much easier to make a calculation. So let's say we have 50% chance to go through B and 50% likelihood to go through C. What does it mean? It means that we are calculating the expected. It is an expected cycle time. So it is not, if we get a one application, let's say, so it will be going either B or C. But on average, the expected cycle time, on average, it will be 10 plus 0.5 multiplied with 20 plus 0.5 multiplied with 10, right? So this is on average, or it is called better, the expected cycle time. This 10 plus 30 multiplied with 0.5, which is then 25, right? 25 days or 25 hours, units of time. Now we can change the probabilities with 90% that the process will go through B and 10% going through C, and this will change, of course, the expected cycle time that we have. It's 10 plus 0.9 multiplied with 20, which is 18, and then 10 multiplied with 0.1, which is 1, and then we will have a cycle time equal to 29. So obviously a higher cycle time because there is higher probability that the application or the outcome of A will go through B than through C. And B is obviously the longer activity. Okay, so far so good. Things seem to be, things are clear. This is, now we have another gateway, so it is a join or an join adding gateway. So always have in mind the token gain. So at this gateway, we will have two tokens, right? Firing here. So once we go out of A, there will be two tokens firing. So one token will be going through C. So let's say, okay, both tokens are created at the same time. One will go through C, and after 10 time units, the token will be here. Do you agree? Now, can this gateway fire when we have only one single token here? No, it cannot. It can fire only if this token also arrives or is out of the activity B. So the gateway can fire, so in order to go to the end here of the process, only if B is completed. So we have the token here at time, let's say 20, 10 plus 10. But at time 20, 10 plus 10, still we are processing the application, let's say, or we are doing task B. So after 20, or 20 plus 10, after 30 time units, 30 hours, let's say, the token will be out. And then once we have both tokens, then this gateway will fire, and then we will go out of the process. So how long it is in order to complete this process? It's 30, exactly. So it is 10 plus the maximum. So when the plus gateway, so it is the maximum of B and C, or the durations of B and C. So it is 10 plus 20 is 30. Yeah, this is a bit more difficult. So here is obviously we have a loop, right? So we have a XOR gateway. So how do we do it? So what do we need here for the XOR gateway? We need probabilities, right? So we have a probability that, okay, so 10 is okay. Then first, for the first loop, or say after getting here, so it will go through B. And once we are here, it can go up, the token can go up, or it can go inside the loop, right? And it can go through the loop many, many times, as long as the application is, some application documents are lacking, so we have to go through the loop many, many times. So let's start with the simplest case that is simplest, which is, let's say it is 100% that we go out, so we don't need the loop at all. So there's 0% that we go through the loop. Then it will be very clear, yeah, it is 10 plus 20, it is 30, both activities are in sequence. But at the time we have, let's say, 1% and 99%, let's say. So there is a probability of 1% to go through. There is a 99% to go through the loop. Things start to be a bit more complicated, but yeah, for those who did, I know, not for those, I know that you know the geometric series. Do you remember that? Yes? Yeah, long time ago, right? Yeah, when did you do them for the last time? Geometric series? During the first year? Second year of engineering? Second year, yeah. Geometric series. Okay, so we start. Yeah, we have a un equal to u0. This is the formula. And then for the geometric series, we are interested in the sum of ui from e equal, let's say, 0 to n. And this is equal to the sum of equal to n u0 qn, which is equal to, I'm doing it here every step by step. Good. Do you remember how we can write this quantity? It's 1 plus q it's very simple. It is 1 minus q, because we have n plus 1 terms. Perhaps memories are coming back. Yes? Do you remember it? Who doesn't remember it? Nothing. Who does remember or recognize again the formula? No? Yes? You recognize the formula again. So, very good. So it will be, so this sum is equal to u0, 1. So what does it mean? So we have 20. So it's like we have here the probability. So it's equal to 20. So first time is 1. So right? 1. And then 0.99 for the first time. So it could be only once, goes out. Or it could be, we can go once again, right? these are all the cases. We would like to have all the cases. So we can go out after one time. So here. So directly we go once through B and then we go up. Right? The probability is very, very low. It's 1% here, at least in this case. Because there's more chance to go to the second. And then we may have the case where we go one time, two times. We may have the case where we go three times. So here, so we have 1 plus 1 plus 1. So 1 is this one, right? And then we can go more, etc. Right? Let's say we have n times. So this will be but what happens if n gets bigger and bigger? So we are going. This goes at least. When n gets bigger, this term will tend to go to tend to 0, right? So when n tends to be big, I don't want to write infinity because this is mathematically important from a mathematical point of view. The loop cannot go indefinitely. At some time it will go out, and this will be equal to 20 divided by 0.01. Right? And this is equal to 2000, right? Right? So the expected duration of that part of the process is 2000 hours, let's say. And here we have the 10, so 10 plus 2000 gets 2010. Of course, here we have an extreme case because we have only 1% probability that we go out of the loop. Perhaps we may have. So the good thing, you don't need to memorize this. What you need to do is you get this 20 and you divide it by the probability of coming out after from the loop, right? So it's 1% is 0.01. So you're dividing 20 with 0.01, and then you will get the expected cycle time inside the loop. Okay, if we have, let's say, 20% and 80%, as I told you, so you don't need to memorize anything. I mean, here, just 20, you divide it by the probability of coming out through the loop, and then 0.8, and then you will find the cycle time, the expected cycle time inside. And it is equal to 20 divided by 0.8. It should be 25 plus 10 is 35. Everything is clear so far? Okay. Good. So this is the main results of our flow analysis. So if we have activities in sequence, we are just adding the cycle times of the activities. If we have an XOR gateway, we are using the probability, so the outcome will go through one of the processes, so we have to use a weighted sum, weighted with the probabilities. Then we have here a the adding gateway. So we use here the max of the cycle times of the different activities. And if we have a loop, we are just dividing the cycle time of the activity between the two XORs with the probability, or dividing the cycle time with the probability of getting out of the loop, which is 1 minus r here. Okay, and having done this, now we can try to calculate, to make the flow analysis of this process, the cycle time. Good. Yeah, we need some more information, right? We need some probabilities. Okay, with this, you can do perhaps the calculations. Don't look at the solution. Don't look at the solution. Let's try to do it together. So the cycle time will be the first one. How to do it? So it is 1 day. Exactly, very good. 1 divided by 0.8 plus. Then we have here for the second part of the, or second portion of the graph, we will use the maximum, so it will be 3 days. Then access applications is very clear, it's 3 days. Plus, then we need to use the probabilities here. Very good. So it's 1 multiplied with 0.6 plus 2 multiplied with 0.4. Yeah, you can help me with making the calculations, or we can go directly to the results here. Okay, here we have the cycle time at each compartment, and then we have a cycle time which is equal to 8.65 days. And now we would like to even go a bit further. What we are doing here is that we are assessing the processing time. So there is a difference between the cycle time. So the cycle time is the time that is required at the end to finish the application. So this is the entire cycle time of the process. But for each of these activities, we have also the processing time. And obviously the processing time is much lower than the cycle time, because in the cycle time we may have some other ways inside the process, some delays or some some waitings, etc. And we use the same formula in order to calculate the processing times at each part of the process map. So we have to check completeness is 2 hours. How long it takes actually? How long was the cycle time? It was 2, right? It's one day. Yeah, exactly. It was 1 day. So here we have 2 hours just to go through that activity. I mean, the activity for checking completeness takes only 2 hours, but because of other waitings perhaps, etc., and then not availability of the people working there, then it will, it will take longer. Now, check credit history and check income sources. So 3 hours, 0.5 hours. So this is the processing time. The assessment of application is 2 hours. And then we have 2 hours and 0.5 hours for make credit offer and notify rejection. We can use the same formulas as I told you. So it's the same thing. And then what we can find that processing time is equal to 8.9 hours. We compare in 8.9 hours to the 8.65 days that are really required to finish the entire treatment or processing of the application. And this will lead to a cycle time efficiency, which is equal to 8.9 hours divided by 8.65, which is equal to 12.9%. So almost 88 or 87% of the time is actually not productive, and only 12 or 13, almost 13% is really productive. And by the way, this is very normal in many organizations, right? So it's normal. Right? Yeah, sometimes when you send to the professor an email, and I say, why does the professor not get back to us very quickly? So actually writing an email does cost perhaps 10 minutes, but the professor is taking 3 days in order to answer an email to us. Yeah, you have here actually why the professor is writing with some delay. Why is writing with some delay or she's writing with delay? Because there are things, many things before they have to be done. There are other emails, there are other work, there are other activities, there are courses, there are exams, there are meetings, there are research, and of course, all of this leads to the fact that for an email of 10 minutes, perhaps you have to wait 3 days, right? How could you reduce the lead times here? Yeah, it's very difficult. So either you increase the capacity. So I mean, yeah, if the professor has somebody who answers the emails for him or for her, this could be done, okay? Or here, perhaps there are more people that deal with the applications. But if you have more people dealing with the applications, this means, of course, more investments from the side of the company. And it's always, they should be outweighing the benefits of increasing the capacities and not letting the capacities increase, but on the other hand, having to incur some waiting time. So this is not always the other thing is that you can improve the productivity. I mean, here you can improve the productivity of people, or you can automate the tasks. Yeah, some tasks could be automated. For example, AI. We know that AI it can help, or it is used sometimes by some organizations, especially for credit insurance, in order to say whether an applicant can get a credit or not. So at the end, it's like a decision tree, right? A decision tree, at the end, you will have a yes or you have a no. Right? So it's going through different criteria. Here we have perhaps only a couple of criteria, but the criteria could be even more than this. Perhaps if people have other mortgages, or if they have other ownerships, or the list can go on and on. What a bank could test in order to say yes or no for a credit application, and decision trees could be used here. Great. Any question? So if not, I will have just looking the time whether we deserve a break or not. Yeah, we deserve a break. Yeah. So what about having only 10 minutes? 10 minutes, let's say we start again at 9:57. Good. 9:57. Okay, the break seems to be very short. Okay. Okay. Normally the students are very on time, so at least so far you have been very on time. Yes, please. We should start. Could you please close the door then? Yeah. Okay. Yeah, let's restart. So we will go to the how of supply chain innovation, and the second part, we will learn a lot of techniques here to improve our processes. Okay. So the first part of we are ready. You are not in time today. So first of all, we have learned how to draw processes using BPMN. Then we have learned how to analyze the processes according to the three categories: value adding, business value adding, and non-value adding. Then we have learned the sources of waste. And then we looked at the how to measure the performance of a process from a time perspective. And now we will see many techniques how we can get better processes. So more or less, how could we improve a process in a systematic way? So what we would like to do is that to identify possibilities for improving the design of the supply chain process. So we start with a descriptive modeling, so an as-is process, so it may look like this. And our objective is to determine the to-be process. So this is prescriptive modeling of the supply chain process in a way that we improve the first one, the as-is one. So that's what we have done before. So we identified a lot of problems with the rental, the equipment rental process, and we would like to improve it. So starting from the description of the process and identifying a to-be state. But we make a distinction between two types of redesigns, of process redesigns. The first is exploitative redesign. Exploitative redesign is an incremental improvement. We are just improving the process in an incremental way. Just small adjustments of the process. And we will understand, we will see how we can make these adjustments by applying certain tools, certain approaches. So we are not putting in question the main process structure. What we are wanting to achieve is small improvement in the process to make it better. Then we have the explorative redesign. So it could be transformational. So it means that we are changing completely the structure of the process. The process may look completely different if we apply certain approaches. So we are putting in question the fundamental assumptions and principles of the existing process structure. And it could be said a breakthrough or radical supply chain innovation. Okay. So this is also related to so-called business process re-engineering. So we would like to restructure the process in a much better way. and we will learn some principles. And I would like that you know these principles, yeah, that you know them by heart. You will see they are very, very logical. So I don't say that you have to learn them by heart and the sense that you are just reciting these principles, because we will do some examples in a way that when you have the examples in mind, you can just derive the principle very quickly, right? The thing is that if you don't know these principles, you may not be able to apply them. So you have to know them, okay? And they are not many, but when you know them, they are really very helpful, very useful, in order to look at the process also critically, to improve it. Good. We will start with an example. And by the way, I would like to start with the transformational ones. So they are more exciting, right? So what could we apply in order to improve our process, to redesign the process in a way that is completely different, that may restructure the process. Yeah, I will start with a case study. Yeah, a very known one, by the way, this one. So Ford needed, so it was, I think it's the 80s or beginning of the 90s, Ford needed to review its procurement process, to do it cheaper, so to cut costs, to do it faster by reducing the turnaround times or the lead times, to do it better by reducing the error rate. Accounts payable in North America alone employing more than 500 people. So when you see this information, actually it is an alarm, right? It is like an alarm. Accounts payable, what does the accounts payable do in a company? The accounts payable. We have the accounts receivable and we have the accounts payable. The receivables are everything that we will get from our customers, right? So this is the money that we get from our customers, right? So we are providing some services or goods to our customers will pay us. And these are people in the accounts receivable are, of course, responsible for getting the money from the customers. The people dealing with the accounts payable, they are the people who will pay at the end the suppliers. So you get some services from your suppliers, you get some goods, raw materials, etc., equipment, repair materials, whatever, and then you have to pay them at the end of the day for the goods and the service. So these are the people. So could you think of a department that is just paying suppliers composed of 500 people? 500 people doing nothing else than paying their suppliers. Okay. Could you please close the just for a couple? Thank you very much. And then once it goes, we can open again the window. Good. And then the turnaround times for purchasing orders and invoices was in the order of weeks. So how does it go? Always we have the purchasing request coming, let's say, from one department. Let's say it could be from production, it could be from the warehouse, it could be from the logistics, it could be from the administration. So there is a procurement request. And then it goes to the procurement department. The procurement department will issue a purchasing order. The purchasing order will be then sent to the supplier. And then this process, just the processing of POs and invoices, would take weeks. So, of course, the automotive industry is complex, right? So we have many components, we have many suppliers, but still, yeah, this is incredible. And they were aware of the problem, and they wanted to improve this. Now, Ford has thought this way. Automation would bring some improvement. It's about 20%. 20% of cutting costs, getting 20% faster. But Ford decided to not do it. The question is why? This is, by the way, a question I would like to ask to you, so you help me to find an answer here. So Ford did not go for automation because at the time, end of the 80s, beginning of the 90s, the technology needed to automate the process was not yet available. So this is the first option. The second option, as a possible answer, because nobody at Ford knew how to develop the technology needed to automate the process. Also possible. Or because there were not enough computers and computer literate employees at Ford. Or none of the above. What would you say? I'm just asking for your intuition. What do you think? So automation is always very interesting, right? You have a process that costs a lot of time, it costs a lot of money. What you would like to automate that process. Why? To make it faster, and then you won everything. At least you think you have won everything. But Ford did not go for automation. Why? Which one would you go for? Which option and before answers? Yeah, you would like to say something? I saw that. B? Because nobody at... There are no skills at Ford? Yes. Good. Thank you. Was not available? Okay, automation was not. Yes? Hmm? So none of the above. Yeah. Exactly. So they had enough computer literate, the automation technologies were out there at that time, but they wanted to have more. So this is, by the way, most of the time what people do, this is a common mistake. You have a process that doesn't go well. What you want to do is that to put on top an automation technology in order at the end to automate something that is anyway not optimal at all. And this is not the way to go, by the way. Every time you would like to automate, don't jump on automation. Look at first at the process, how the process is done, how it is completed. Improve the process. And once you know that the process now is really great, excellent, working well, only then you should think about automation. Okay? Because otherwise, I'm sorry for saying this, but if the process is garbage, you are just automating garbage. So we don't want to automate garbage, right? We want to automate good things. Okay, so I would like to give you a feeling for the as-is process. So the starting point of Ford, how the process and the accounts payable was completed at the very beginning. So, of course, there is a purchase request coming from some departments of the company. We don't represent it here, okay? So production department could have a request, and that request arrives at the purchasing department. The purchasing department now, after making some checks, etc., can submit a purchasing order to the vendor. Right? So far, so good. Everything is fine. Once the purchasing order is submitted to the vendor, then there is a copy of the purchasing order that going to the accounts payable. So these are the people that will be responsible for the payment of the suppliers afterwards. Seems fine, everything is good. Yeah, please, if you have any disagreement with the process so far, tell me, okay? Then what will happen after some time? Obviously, the vendor, after some time, will deliver. Who will get the goods? Who will be? Yeah, the company, Ford, right? Ford will get the goods. And there is a receiving department, right? So there is a warehouse reception, department that will perhaps get the goods, will count them, will have to sign that they got the goods, etc. So it's like the supplier will come, put everything and go away. No, it is a process that is formal where the company would like to assess everything and check that the goods that are delivered are really delivered. Right? Then, what do you think what comes next? The receiving department will submit the receiving document to the accounts payable. So far, so good. So after some time, the vendor will submit an invoice. And then, at the end, what Ford will do, will make the payment. So my question to you, as supply chain innovation expert, what is wrong with this process? What's wrong with this process? Seems logical, right? At first glance, right? Please. I see you would like to say. The accounts payable department needs to be. Yeah, they could be sitting, but in the organization you may have people, that are responsible for this. Yeah, I went to a company last week, and then they told me here is our supply chain management. So we had 50, 60 people doing supply chain management. People doing procurement, people doing distribution. And you mean he has split it? Yeah. The one that is making purchasing is paid, or what do you mean? I'm not here very well. Did you hear your colleague? No. Good. So you're saying, is it necessary to have this and to have this? Yeah, because look, these are two different documents. One document is internal, right? One document is that to signal to the accounts payable, you may get an invoice in the future because we sent a purchasing order to, not you may, you will get an invoice. And then, of course, after some time, after the delivery, the supplier will send an invoice to the accounts payable. So otherwise, if the accounts payable will get an invoice from a supplier without having received a reception document or the purchasing order, say, what is the supplier doing? So it's just sending us an invoice for nothing. So right? So it's a problem. So you will not pay an invoice if you are not sure. So it is a big organization here. We're not talking about a couple of goods. So we are talking about perhaps thousands of components and goods that an automotive manufacturer is buying. So you have to have somehow a process in order to be sure what you pay is for something that we really got. Yeah, it's something that is important for the business, of course, yes. Yeah, otherwise we'll be paying invoices perhaps that for which you did not get anything, and this is problematic. What's wrong with this process? Yeah, why do they have 500 people? Perhaps the benchmark at that time, it was much better. Other companies, they did the job with much less people. And what's wrong with this? Any more ideas about the problems of such a process? Look. And it was problem. Yeah, at Ford, what actually led to the fact that the number of people is very high? Look, when you get the copy of purchasing order, then the receiving document, then the invoice. What do you think? When does the accounts payable pay the invoice? When, under which conditions, the accounts payable will be ready to pay the invoice? Exactly. So they will pay the invoice only when they are sure that the quantity, the goods, the price, the cost, everything that is on the purchasing order is the same as in the receiving document, as the same in the invoice. Because it can happen that you are purchasing something, but you receive something else. And you get perhaps an invoice on something completely different. By the way, mistakes can happen. And I don't know, when you get an invoice, would you just pay the invoice like this? Of course, you would look at the invoice and say, okay, what did I get for that? Yeah, is it actually equal to what I got? If not, you'll say no. What you will call your supplier, you will call the provider, service provider, you will call whoever, and you will try to understand what the problem is. Now, look at this. So this is what you do. But think of a company with thousands and thousands and thousands of suppliers and thousands and thousands and thousands of components and goods that have to do all of these checks, and then there may be problems. Invoice is not equal to receiving document, is not equal to purchasing order. What you will do? You will call the purchasing department. Yeah. Is it really what you have asked for? Yes. Then calling the receiving department. Did you really receive these quantities? But these quantities, they are different from the purchasing orders. They say, yes, this is the quantities what we got. Okay, and then the problem may be with the vendor. Then they have to call the vendor. Okay? So, but you sent us deliveries that are not matching the purchasing orders. And your invoice is actually matching with the purchasing order, but is not matching with the receiving order. And then they have to think about, okay, how to, they would like to compensate. Perhaps they have to send the missing part of the purchasing order. They may have to correct the invoice because the invoice was wrong. They were just invoicing the wrong things. It was a higher invoice than actually expected. And this is only for one single component. Multiply this thousands of components. You will find the fact that these 500 people is actually required. So you see, a process, and this is what I would like really to tell you, a process that may seem at first glance really perfect, really a process that is, that should be doing well, but when you dig more into it, you find a lot of issues. Now, how could Ford deal with this problem? In order to improve it. So, okay, what they did is that let's put a database where we are placing your purchasing order. So, very simple. Whenever the purchasing department gets a purchasing request from any department company, any individual from the company, it is approved, then they will issue a purchasing order, but before issuing it, they will be put in a database. And the database, of course, it is accessible to all the people working in the organization, or at least to the people that are involved in that process. Once it is put in the database, now the purchasing order can be submitted, can be sent to to the vendor, right? What does the vendor do after some time? The vendor will, of course, send the goods. And here's the thing. Here what is the big improvement in that process. So what was the job of the receiving department in the as-is process? The job of the receiving department was, the supplier tells the receiving department, I brought 100 components for, for the car, I don't know, whatever it is, 100 components. The reception document will count them, perhaps will look at the references, and the okay, sign, and then. Now the reception department will not do only this, because the reception department has now access to the database where the purchasing order has been actually stored. Now they can get access to it and compare what the received documents are, whether they match with what is stored previously by the purchasing department in the database. And this way, they are able to actually eliminate the problem that has been, actually worsening the performance of that process. If it is everything is okay, of course, they will be receiving it, and because they have access to it. And if there is a problem, it will be signaled quickly, right? It has to be solved. Then, they require the purchasing department, do they have to accept the goods or not, because it is not matching with the purchasing order, and then they have to find a solution. Perhaps the supplier can say, okay, I can send the missing components very quickly, or I will just bring back the products with me, and then I will, tomorrow, I will bring the right components wherever the problem is. So it can be, the problem could be detected very quickly, and if everything is okay, then the reception will be done. Now, what do you think with respect to the accounts payable? The accounts payable itself has, of course, access to the database, right? What can they do?
They can verify.
So, actually, this is very important. The accounts payable may not even wait for the invoice. The received documents, the delivered ones, are matching with the purchasing orders. Okay, so we can directly trigger the payment. Okay, so the accounts payable, they can have access to the database. Everything is okay, everything is fine. Now the payment can be triggered. Does it make sense here? It makes a lot of sense instead of the process that we have. Okay. This is, by the way, called evaluated receipts settlement. So, we got the evaluated receipts. So this is what the accounts payable does, and then we are paying just by evaluating the receipts. The receipts are equal to the purchasing order. We can pay. Now, what is the outcome of this process? 75% reduction in headcount. So from 500 people to just 125 people. Simpler material control. More accurate financial information. Faster purchase acquisition, and less overdue payments. Because, in practice, let's say if your supplier gives you 2 months, 60 days for paying the invoice, and you don't pay in time, what happens is that you have to pay a penalty, right? You cannot say, okay, because my process is too slow. No, it's not my problem. You have 60 days to pay after issuing the invoice you have to pay after 60 days, right? So these kind of problems, these kind of overdue payments do not happen anymore because of the evaluated received settlement. Actually, they can trigger very quickly the invoice. Of course, in practice, yeah, companies will not, yeah, after having received the goods, they will be paying almost instantaneously because they would like, of course, to have some buffer. Yeah, this is important. If you have 60 days from supplier to pay, then you may use actually these 60 days in order to ensure that you have more cash in the company. Yeah, some companies, some suppliers, perhaps you may negotiate to pay after 90 days. Some suppliers perhaps would like to have after 30 days, but they would not get the payment instantaneously. But still here, things can go wrong and overdue payments can happen, and therefore with that process they will not be, they will not occur at all. Now the lessons, why automate something we don't need it to do at all? So why having all of these 3 documents to be compared, etc. So if we have done automation, what the automation would be about, say we will compare, so instead of having people comparing the 3 documents, invoice, reception, document, and purchasing order, so now, okay, we don't even need that. We don't need this automation at all, right? Because we have changed the process completely. And automate things that need to be done, right? This comparison, invoice, document of reception, and purchasing order is not required. So, yeah, we don't need to automate that. And therefore, it was a big wave of business process re-engineering in the 90s. Yeah, it is called basically just summarize what Hammer championed in 1993 and Hammer in 90 said, don't automate, just obliterate. Just eliminate the things that you don't need and just focus on the parts of the process that are really, really useful for the organization. Okay. Any question in this regard? So I cannot emphasize enough how important is our processes in supply chain management, right? So processes are everything. If processes are doing well, then the whole organization is doing well. And yeah, I mean here not only manufacturing companies, also service companies. Perhaps in manufacturing companies, yeah, you may feel it somehow. For example, if you buy a kitchen and you get some issues with the kitchen and you have to go through a claim process, you will understand whether the organization is doing well or not. So you have some claims, things are broken or they are not good in your kitchen, a kitchen that you paid a lot of money for, right? You have paid a lot of money, and then you would like to issue a claim, and you are expecting actually that the company will deal with your claims, and you will understand the process inside the company once you have that claim. So, did you make, for example, returns with Amazon? Who has made already a return of a product with Amazon? How does it work? How does it work? It's easy. Absolutely. Very good. So how is the process? It's easy, right? What do you think? What is, yeah, and from that perspective, how would you qualify that process as excellent, right? Yeah, so at least the customer will see that it is an excellent process. And this is an important process in supply chain management. So in e-commerce, supply chains, the return process is so important. So take some examples of fashion companies, right, that are sending deliveries to their customers, trying them, not fitting, sending them back. It's a big question mark, right, with respect to sustainability of this process. But from a performance point of view, from the point of view of the customer, yeah, This Amazon is doing the job well. Have you ever bought a kitchen? No? Yeah. Think of the claim process also when buying a kitchen. Yeah, how is the reputation of the organization with respect to the claim process once things go wrong? Because believe me, a lot of things can go wrong. And then you will have a feeling how the process is doing well when you start that process with the organization. When you call and you don't have anybody, let's say, taking the phone, you start, the adrenaline, level will start being higher. Insurance with the same thing. It's the same thing. So if you would like to insure something, let's say you insure, I don't know, your house, or you insure your car and whatever, and something happens, of course you would like to get a good service. Claim process is part of your the supply chain. The return process is an important part of the supply chain. And you can start understanding whether the process is going well or not. Okay? So, yeah, we have to be really, really careful about processes and supply chain innovation, because supply chain innovation, we have seen it last week. Okay? So you can change the notes. It is a good opportunity to, because this may be a question in the exam. Now, what are the three dimensions of supply chain innovation? It could be the supply chain configuration or the supply chain structure, the configuration of the nodes and flows. It could be the business processes. This is what we are doing. It could be the technologies, of course. This is another feature in the supply chain innovation, so that we can improve our supply chains. Yes, please.
Can we just say that before automating, we should follow the approach that we first look at the process structure instead of automating each department?
So we have to automate a good process. So, as I told you before, if Ford would have automated the process that they had at the very beginning, process where the accounts payable has to compare 3 different types of documents. The automation would be about comparing whether invoice is equal to reception document is equal to purchasing order. So this would be the automation about. So you are just automating a bad process. If you do it this way, you are more or less integrating certain tasks, especially in the receiving department, that haven't done so far. The receiving department was so far doing just, okay, I got these goods, I just signed that I got these goods, and nothing else. Now the receiving department is doing a part of the information processing, is that making the comparison between what has been received and what has been actually ordered. Right? So the automation here would not come up with a solution. You have to redesign your process. So in general, improve the process and then automate. Don't do the other way around. And I think 3 or 4 lectures ago, I told you about the study by Semshi Levy and Heinrich, and where they captured data from many supply chains, and they found actually that supply chains with bad processes and excellent technologies, they were the supply chains that performed worst. Those with simple technologies, unsophisticated technologies, plus immature processes, they were even better than the ones with bad processes but with excellent technology. So putting an excellent technology just on a bad process is going to make things even worse. Okay, from this, by the way, so what we will do is that we will distill some principles. We will do a distillation of important principles independently of this example that we can use whenever we have a supply chain process or process like this in order to improve it. So the first thing, the first principle is capture information once and at the source. So this is a principle. The second one, I will go through them quickly, but we will detail them afterwards one by one. Subsume information processing into the real work that produces the information. Have those who use the output of the process drive the process. And fourth, put the decision point where the work is performed and build control into the process. So these are 4 principles for the redesign of supply chain processes. Yeah, it is actually for a structural redesign. So I tell you, yeah, you have to know that. And then you will see once we deal with the examples that you don't have to learn them by heart, but you will understand them and then you'll be deriving them whenever you need them. Okay? So during the exam, you cannot tell me, yeah, this is learning by heart. No, it's not learning by heart. Right? It's understanding how these principles function. And we will see that. So capture information is not the source. Yeah, this is actually what Ford did. The purchasing order, before sending it to the supplier, it has to be stored in the database. It is stored once at a time, right? So, and that's the source. Who created that purchasing order? It's the purchasing department. So it is inserted database by that department. So all process workers access the same data. Don't send around data, share it. I don't know whether you have worked already on assignments, perhaps when you do the work on assignment, of course, you will need a way or somehow to meet and work together and to exchange ideas. But once you have, let's say, a document, or you would like to make your presentation, your PowerPoint, some of you may say, okay, I will write something and then I will send around an email with a PowerPoint. But perhaps some of you would say, no, don't send emails. The professor has said, according to the first principle of the redesign of processes, we should not send data around, but we should just share data. What does it mean? It means that we will put the data on OneDrive, and in this way, anyone in the group, everyone can have access to it, and change the document, can work on the document. And every time you access to the document, you will have the current, the most up-to-date version of the document, right? So this is, by the way, the principle that perhaps some of you is already using, but this is an essential principle. Don't send data around, just share. Okay? So this is also what some companies have been using in the past. For example, I don't know when you'd like to have like travel. When you'd like to travel with the airplane. Yeah, still of course you can do it. But I remember many years ago, when I would like to travel with the airplane, I have to go to the agency and then give my data to the agency. They will put it in a computer and insert in the computer, and then they will issue a ticket, a flight ticket. But it was really a long time ago. Did you have this? No, perhaps never. So you buy online, right? And when you are buying online, you are providing all the data that is required actually yourself. So more or less, you are not sharing data. What you are doing is that the customers are capturing the data themselves. So you are inserting the data, and that data is actually accessible to all employees of the company. Customers are performing the tasks themselves. Even perhaps in some online banking companies, even when you are opening an account for a bank, right? How do you do it? Who went to the bank, to the physical bank, and opened an account? So I did it also. Who did not go to the bank and then open the account online? Yeah, put everything. Still is, yeah, you have been working for the company actually, yeah, actually capturing all the data. And we went to the bank, the physical bank, and then provided our data, and then they opened the account for us. So there are different ways. So here, perhaps for the flight tickets, it's mostly online, but for opening an account, which needs a process which is clear, it could still, nowadays, it can go in both ways, physically, or so the customer is working, or the customer is just talking to somebody in the bank who is then working and then capturing all the data. Then we have principle 2. And principle 2 is subsume information processing work into the real work. Very interesting. Subsume information processing work into the real work. Yeah, what is the real work of the receiving department in the case of Ford? What was the real work? No. In the as is process, I mean, what is the real work of receiving department? The real work that is done.
To receive the goods and store.
Exactly. So the real work of the receiving department is to receive the goods and to store them in the warehouse. And the idea here is to integrate the information processing into that receiving task. Okay, so in the first as is, it was just reception and storing. And in the to-be process and the improved process, it is receiving and storing, but also comparing the goods received with those, with the document in the purchasing order stored in the database, right? And this is principle 2, and it is called evaluated receipt settlement, because when receiving the products, record the fulfillment of the purchasing order and then trigger the payment. Okay, so this is what the second principle means. And this is, by the way, a very interesting principle. Push the, or have those who use the input of the process drive the process, or push the work to the actor that has incentive to do it. What does it mean? I have to push the work on those that really need the output of the work. Yes, don't use it in your, right? Yeah. By the way, if your colleague is incentivized to get the output, then push the work on him or on her. This is very, very natural. And I will give you some concepts, by the way, that use this principle. The vendor managed inventory. Who is actually interested in selling? The supplier or the manufacturer or the retailer? So you have here a short supply chain, let's say, just for simplification. We have here a supplier. And we have here retailers. The retailer will look at the supplier and say, yeah, you would like to sell it. You would like to have a space in my retail store in order for you to sell. So you have to make the management of inventory at my store. I will not bother with that. And based on that, so pushing the work on the one that has incentive to do it. The supplier has incentive to sell, because the retailer would say, yeah, if you would not like to get the space, I will switch to another supplier, because here, of course, they have the power to do that. Push the work on the actor, the supplier, that has an incentive to do it. So, manage the inventory at my store. as long as I have on my shelves your product, you'll be able to sell. If you don't do your job, and there will be no products on my shelves, you will not be able to sell. So the incentive is with it. Okay? So this is vendor management. So it uses this principle. Is a powerful principle. You have to recognize who has an incentive to do something. If somebody has an incentive to do something, push the work on him. Yeah, and then scan-based trading. What is scan-based trading? Yeah, scan-based trading, it works, by the way, in construction companies very well. So, yeah, for example here, we have a supplier that delivers materials and tools and equipment, whatever, to a construction site. Then we have on the construction site a container with all of the components, the materials, the equipment that are delivered by that supplier. Okay? So who has the incentive to sell or to put or to make the components and materials available for the construction company? It is the supplier, right? Yeah. Think about the process that we had in Build It. So the site engineer has to make a request in order for a certain equipment to be found and then rented. Okay? Here, what about now not bothering at all? And then for all equipments that we may use frequently, we have a supplier that makes a container available with all of the required equipments, at least the ones we are using frequently. And whenever we need these tools and equipments, we just scan them, and then all of a sudden we can get an invoice, yeah, of course, because then the system has recognized that we are using that equipment. So here we have shared on site, for example, in a container. Then the worker goes to the container, scans the equipment, scans the material, and the system will record that data and will trigger the supplier to send an invoice. Okay? So this is actually, you see, so instead of doing this request and then having that process that Build It going again and again and again, what we have here is that we have the supplier that are putting all the equipment that is required, and then whenever we need them, we scan. It means that we took a component or a material or a tool, and then we will get invoiced accordingly. They are different here because the evaluated receipt settlement is completely an internal process. So we are subsuming actually into real work some information processing activities. So the receiving department is, so we are not thinking about this. The receiving department is not only doing reception activity, but also doing an information processing activity, right? So we are only looking at a company from an internal point of view. Here, we are actually getting some activities we used to do ourselves, we put them on our supplier. We just push them on our supplier. Right? This is completely different. You understand? So in the, you can look at it like this. So in the evaluated receipt settlement, which is based on principle 2, subsume information processing into the real work, we are looking only on the internal organization. Okay? So it is in our case, I refer always to our case, the receiving the department that is now doing information processing activities in addition to the physical activities. Now, for principle 3, we are pushing the work on the one that has incentive to do it. We have two actors, actor 1 and actor 2. So we are here. This is our internal organization, right? We are asking ourselves, who is actually incentive to do the work, to do the process? Is it us or is it another party? And we notice, we observe that there's another one who is interested. So here's the supplier that is interested to sell, right? And because of that, we're pushing the work on it. Of course, there would be an invoice afterwards, etc. But yeah, this would be more or less a consequence of this system. So we are not managing our inventory ourselves. We are letting somebody else doing it for us. Does it make sense now? Good. So when materials are delivered to extraction site, ownership still belongs to the supplier. So you see, and this is relevant. So as long as the materials are placed in the container, they belong to the supplier. They do not change ownership. The ownership is with the supplier. Starting from the moment they are scanned, because this will signals getting the component and using it perhaps afterwards. This will trigger an ownership change from the supplier to the manufacturing company. Okay? So there will be ownership is transferred, and then the buyer will be charged, which is the construction company. Does it make sense? Did you understand everything? Yes. Yes.
So, I was confused about this incentive part.
Yeah. Of course, yeah, incentive, it does not mean that every time you would like to push the work on your supplier will say yes. No. It should be, of course, taken with a bit of grain of salt, right? So, but if you have the power, I mean, you are a big construction company, and then, yeah, the supplier will be happy to serve your company. Yeah, if you think about Walmart as a retailer, yeah, a giant company working with suppliers, the suppliers will be happy to work with Walmart, and whenever Walmart tells them something, they will be doing it. So we have to take that into account. So don't think also that it will function automatically without other aspects taking that should be taken account. Yeah, the power. There is some power asymmetry right here. Yeah, obviously the retailer has more power than the supplier. But yeah, it is dealt with case by case, right? So yeah, it depends on how strong your negotiating position is. Because you are pushing work on somebody else, so he or she may say no. And then, yeah, if they say no, you have to think about it, whether you change the supplier or do still work, finding a deal with each other. But sure is, you have to try it. You have to think about it. Perhaps it's not for all components. You can say that for the frequently, because it's even for scan-based trading, it could be even if you do a negotiation with a supplier, they may say, this could be advantageous for you also. Instead of making many deliveries, instead of having to deal with many purchasing requests, etc., you're filling this container And then whenever we need something, so we are pushing everything once, and then whenever we need, we will be not bothering you, and then the system will be just sending an invoice to us. And that. So, of course, in a negotiation, you may focus on the positive aspects from the supplier side, right? But the principle is called like yeah, containers are, yeah, in the first class, we understood how important containers are as a standardized box for shipment. But if you remember at the very end of the course, I told you that there may be other uses. Yeah, it could be as a small warehouse, as a movable warehouse. It could be, you can use it also as a server where you put servers. It could be, yeah, they are very versatile, right? They're very versatile. How the ownership transfer is pretty simple. So it's when you go to let's say to a retail store and you buy, let's say, coffee. From the moment you give the money, yeah, there is a ownership transfer. So here it's like when the system detects that you scan that tool or that material, yeah, it will signal that it is in use. So it is no longer the ownership of the supplier, it is now the ownership of the construction company, of the buyer, and then an invoice will be issued instantaneously. Okay, I have another example. Let's finish these 4 principles and then we'll have a short break. So here it is also we can think about improving this process. So this is an insurance process. So this is a client that has a car. This is the insurance company, and then this is an approved glass vendor. Let's think that the client has a problem with the glass of the car. So the first thing, the client goes to the approved glass vendor and actually requests for a quote. How much will it cost in order to change perhaps the glass of the then the client will issue a claim. Okay? So, okay, I have a broken glass in the car, and this is how much it will cost. The insurer will be examining this, will authorize this. Yeah, let's say authorization. Then the client will pay, and then once the client gets paid, he or she can ask for reimbursement, and then the insurer will pay because the insurer has already authorized the change of the glass. Now, how could we change this process by using this principle? Yeah, push the work on the actor that has incentive to do it. So now, who may have incentive to do the work here? Who may have incentive here? Who is the supplier here? The glass vendor. Okay. So what about having the process this way? Instead of having all of these complicated things that the client just drops at the approved glass vendor, the claim now is not issued by the client, but it is issued by the approved glass vendor. And the insurer will be just authorizing and paying. And then the service, of course, can be given to the client. So it is much, much easier to have and less complex to have this process than having it the way we had it before. So the client will drop at the glass vendor. The glass vendor will make the claim that there is a client that is registered at that insurance company, that specific insurance company has some issues, and this is the issues, and this is how much it costs. And because in the first process, it was the client that had to get the quote and then make a claim, and then it has to be authorized and paid by the client, and then the client has to be reimbursed. But now, the payment is between the approved glass vendor and the insurer, the client will not be intervening at all, right? So this will reduce that, the complexity of the process. And the claim, because it is done by the vendor directly, so the authorization, will be also provided directly by the glass vendor, and there is no, let's say, unnecessarily processes taking place. Make sense? Right? Make sense? Then the principle 4, and then we will get a short break. Yeah. Put the decision point where the work is performed. Put the decision point where the work is performed and build control into the process. Yeah. Think of the over-processing that we had before. In the case of the site engineer, the works engineer. So every time the site engineer is having a request, that request necessarily has to be approved by the works engineer. Right? So, and also, there is the clerk, of course, doing the work for the site engineer to find an appropriate equipment. Now, why having always the works engineer that could be in trouble, that could be busy, why having always the site engineer, the manager, always approving the rental request of the site engineer? Why not empowering the site engineer, empowering in the sense that we are providing decision responsibility to the site engineer, that he or she can decide about certain equipment, about the equipment to be rented or not. So in this case, we will not need the approval from the works engineer. So the one who needs the equipment will decide and make the required approvals in order for the equipment to be rented. So this will reduce a lot the complexity of the process, and then it will make it even faster. And here, of course, some people may say, but we should at least have the 4 eyes principle, at least 4 people, or 4 eyes, I mean 2 people, that one has to approve this, otherwise there will be unnecessary purchasing orders going to the supplier, or there will be equipments that are rented but not required. We need some approval. And here, what the principle tells you is okay. But instead of having 100% check of all rentals that are posted or submitted by the site engineer, what we can do is that we can build some statistical control. I mean here, let's say the works engineer can take 20% of the equipment rentals that have been placed by the site engineer and make a statistical control whether it's okay or not. And we know with statistics, we can have also a determined good number, a sufficiently low number, that we can have high confidence in the fact that, most of the rentals have been doing, or they went almost very well. Okay? So instead of having 100% of control, we may have statistical control. Instead of 100%, it's just 10% of control of these equipment transfer requests. So, empower the process workers. It means we provide process workers with the information needed to make decisions themselves, and then replace back and forth handovers between the workers and managers, which is a transportation way. So the back and forth between site engineer and perhaps works engineer. Of course, we do not see behind what is happening in that process, because if the works engineer, the responsible manager, does not approve the rental of the equipment, the site engineer may get the phone and then very angry, calling the responsible engineer, no, it's not like this, and then yeah, it can get a bit of problem, can get into a conflict. So, but we have to think about designing controls, right, into the process. Yeah, this is the equipment rental process that we had before. Okay, so principles 1 and 2, when we apply principles 1 and 2, so capture the information once and at the source. When it is needed, site engineer queries the supplier's catalog, selects equipment, and triggers PO. So here we have a database, let's say, with a supplier's catalog. It can be consulted, can be is available, then selects the equipment and triggers the PO. So we are integrating the information processing so into the real work. So here the site engineer is not just doing the real work is to notice that there is a need for an equipment. Now, the site engineer noticed that there is a need for the equipment, but also is doing the information processing, that is the selection of the equipment and placing the purchasing order. Now, the principle 3 here, which is pushed to work onto the one supplier or the actor that is that has incentive to do it. Supplier stocks frequently use the equipment at construction sites. Site engineers scan to put them in use. And then principle 4, the site engineer is empowered with the authority to run the equipment. Works engineer just performs statistical controls. So instead, the works engineer approving everything, the works engineer now is just doing statistical control. Let's say every 4 rental equipment rentals, yeah, the works engineer is just checking once whether it is okay or not. And in this way, by using this, we are able to improve our process that we have discussed before. Any question on this? Will you use these principles in the future? At least have them present in your mind. When you have them present in your mind, you may see different ways of doing the process. Okay. Yeah. Let's have. So there has been a lot of information perhaps with these processes, principles. Let's have 10 minutes in order for them to get better settled in the mind. 10 minutes, and then we continue at 11:20. 11:20. Good. Then, yeah, we have seen the explorative redesign of processes. So actually, we can in this way restructure the process completely. Now, what we will see how we can improve the process incrementally. So we will see also many principles that you can use, simple principles, like the ones we did. You have to know them also, because they are powerful, they are important. So, yeah, let's go for them. Okay, we call them heuristics. Yeah, we can call them principles. Heuristics because you are not very sure that when you apply them, you will get an optimized process, okay? So it is a heuristic, so you may get a better process, you may not, but you have to check this out. We have three types of heuristics. We have task level heuristics. So you have flow level, and we have the process level. So the process is, there are many tasks inside, many activities inside. At the task level, we talk about task elimination, composition, and triage. We have the flow level, we talk about resequencing and parallelism enhancement. And then at the process level, we can use specialization and standardization, resource optimization, communication optimization, and automation. Okay, so these are the principles, and then let's look at them. So we will start one by one, and then think of some examples. Okay, heuristic one is simple. Yeah, think of eliminating some tasks. Yeah, ask whether the task is necessary or not. So eliminate non-value adding steps wherever these can be isolated. Look here. So yeah, like forward, send, receive. We know that they are handovers. These handovers, they are not value adding. We should eliminate them. So in the first process, we have check manually as a necessary step inside the process. Whenever we do something, then we have check, a certain check, and then we continue with that. So it is a necessary part inside the process, the first one. For the one below, we are separating it. So we have an auto check. We have an XOR here. When I have an XOR. So perhaps it is 80%, let's say, it's 80%. In the cases, it will be an automatic check, right? And 20%, it will be check manually. So we are eliminating the check, the manual check from the process and putting it as a optional, and yeah, only for some types of, for some of tasks or some types of outcomes. Then we do the manual check. Okay. So this is the principle of elimination. Always we have to consider the trade-off between the cost of the check and the cost of not doing it. Yeah, it's very easy to say, okay, we need a check here, we need a check there, etc. The more checks we have, the better. No, it is not true, because the checks, they are slowing the process, and also they cost money. You should have people or equipment, spaces, perhaps, in order to do the checks. And every time you do it, you have some cost. So we have here to outweigh both trade-offs, both costs, right? Yeah, what cost is higher? It's the cost of checking or the cost of not doing it. Examples, we have the procure to pay process. Some types of employees can trigger isolated purchases below 500 euros, let's say, without supervised approval. So we are eliminating the approvals for purchases below 500 euros. Okay? In many companies, you have it like this. Before starting to work at Polytechnico, I have worked in a research organization in Germany, and I was a head of research unit, and I could actually release purchases. Let's say if I would like, until 500 euros was okay. So I do not need the approval of nobody. Okay, if I would like to buy books, or I would like to buy I don't know, for a workshop, some facilitation stuff. Yeah, posts, and I can do it myself. I can release the order, and then I will get it. But if I would like to pay, for a software that costs 25,000 euro, because we have to do some simulation, stuff with it. So yeah, then I need the approval of the director of the institute, because yeah, the budget, although it is from my budget in the company, but in the research organization, but I need still the approval. So here it is actually elimination of certain approvals for purchases until a certain threshold. Invoice payment. Invoices from trusted suppliers under $100,000 or euros are not checked on a one-by-one basis. So if you have a trusted supplier and then sending an invoice of 1,000, you say, okay, yeah, they are trusted. I will not check all of them. I will just trigger the payment more quickly. Perhaps I will make some small control, and that's all. You see? So this is a way how to simplify the work, and then still you may say, okay, there's some risk. There is. But whether, of course, the risk can be translated to some cost, is that cost really higher than the cost of not doing it? So having people just spending all the day making the checks of very small invoices. So you have to think of it. Perhaps have these people doing different tasks that are more productive would be better. Of course, this is this is a heuristic. You can think of it. Yeah, it is not sure that it will lead to a better process, but you can envisage applying it. And believe me, in this case, you find many organizations using these two types of improvements, let's say, coming from the elimination procedure. So procure to pay, in general, under 500 euros, perhaps 100, some organizations, and 150, some organizations perhaps under 1,000. Yeah, it is just released without any more approvals. Then we have heuristic 2, which is task composition. What does it mean, task composition? So it means out of 2 tasks, I'm making one single task. I'm putting 2 tasks together. So in some cases, if this is what could make my process better, in some other cases, perhaps task decomposition is better in the sense that I'm making out of one single task 2 different tasks. So it depends on the context, right? Consider composing tasks to eliminate transportation. So here, when we do them together, we are reducing transportation. And consider splitting a task into 2 and assign to separate specialized sources. For example, if you would like to make it perhaps faster, you say instead of having one big task done by one single person, what you can do is that you split it in 2 tasks, and then you assign these 2 tasks to specialized people with competencies in doing both subtasks in a competent way. So it's really depending on the case that we have at hand, but those both principles, heuristics, could be very useful. We can see here some examples. The procure to pay process. Yeah, it is an example of composition. Merging 2 checks. Check necessity of purchase and check budget. You know, when do you make a purchase in a company? You make a purchase, of course, when we need the object to be bought, to be purchased, right? So there is a real need. And then when we have budget. So if we don't have budget for paying things, of course, we will not be able to buy. And in budget, it does not mean when you don't have budget that there is no money in the organization, but it may be that you just finished your budget. Let's say, yeah, you have a budget for buying books, yeah, 1,000 euro for buying books, and you have been really, during that year you have been reading a lot, and then the company or the research institution is giving you this budget, and then by September you have just spend all of the money for books, then you have to finish the year without money for books, so you don't have budget anymore. It does not mean that there is no money in the institution, no, but the budget allocated for what you, for the books is over. Okay, here are the ideas, put them together, and I think this is very evident. It's very natural to put, I will check whether I have budget, and it will be checked whether the good to be purchased is really necessary. And then we may have a decomposition example. So here, you have a client. Let's say you are making customized goods, a customized product. It could be a machine, or it could be a car, it could be whatever. It's not important what it is. Yeah, let's say it is a customized good. And then we have here prepared code. Right? What is prepared code? It means that the customer, let's say, would like to have a customized machinery, and the customer would like to know, what are the costs of this customized machinery, and when it will be delivered. Yeah, let's say you'd like to buy a kitchen. Yeah, let's stay with the example of the kitchen. The kitchen is, of course, customized. You might buy a kitchen by just saying, okay, I'll just make the kitchen and then I will pay whenever you ask me for paying. No, you'd like to know before when the kitchen will be delivered and how it will cost. This is the minimum. The same in the industry. Okay, this preparing code, in order to do it, you have to do, perhaps it's good to separate it in 3 tasks. The first is prepare bill of materials. Then we have prepare production plan. And estimate costs and delivery time. So, prepare bill of materials. What is the bill of material? The bill of material is, is the tree with the components required to make the final product. So it is a customized product, so the company has to know before what are the components required in order to make the customized product. For example, for a kitchen, you may have some specific equipment that you would like to have, specific furniture, etc. So there is a bill of material that has to be created. Right? Then prepare the production plan. What is a production plan? No? How to plan the production? Exactly. The process in production. It means the equipment that will be required in order perhaps to make the different components and to assemble them. Right? So we have here the bill of materials. In order to make this product, we need equipment, right? We need a certain flow inside the organization, inside the production flow, in order to make them. And once we know which machines, perhaps which equipment, which stations, etc., will be used, so here equipment, machines, that will, people, resources in general, that will work on it, we can estimate the cost. Yeah, we can estimate the cost and we can estimate the time, because Okay, we know which machines, etc. We know about our costs. So this is a task of composition, which is about preparing code. By the way, in the meantime, when you go, let's say to IKEA, for example, this process is automated. Yeah, it's automated, of course, in part. So for a kitchen, actually, you should go to IKEA, and then you will have an operator working on a configurator. The configurator, so more or less you are adding components inside the furniture, inside the kitchen, and then based on these components, the configurator will make calculations of the costs, and at the end, the configurator will tell you when that delivery could be made, right? So it is, in the meantime, it is in part automated in the furniture industry. You may have it in machinery, perhaps in machinery. It could be supported by a configurator, and it may be that people still have to work on it. So it depends. But yeah, definitely it is a decomposition task. Then we have a triage. So it is divide a general task into two or more alternative tasks. So from T1 to T2, we can have a XOR, and then we can go either to T2A or T2B. Or we can generalize tasks. We go from a structure like this rather to a structure that is more generalized. It depends on the context. So we have here a specialization example in the case of the triage. So procure to pay. Separate approvals of small purchases, medium purchases, and large purchases. So instead of having approval, purchasing request, and then approval in general, we will have a process like this. We have the request of the purchasing, and the approval will be different depending on whether it is, let's say, approval perhaps under 500 euros, we don't need any approval. Then between 500 and 10,000, I'm just putting here examples, there will be a certain approval. For example, it can be made by the director of the department, and if it is bigger than 10,000, the top manager of the company has to approve this spending, otherwise it is not done. So it's like, instead of having everything collapsed in one single activity, we are distinguishing between different cases, and for each case we will have a certain process. So small, medium, and large purchases. And then generalization example, make to order process, integrate code preparation for 2 product lines into one single task. So instead of having, let's say prepare code for product 1 or P1, and prepare code for product 2. We are generalizing, and then we are making prepare code for P1 and P2 together. So whenever we have a preparation of codes for each one of the products, we will do it with the same resources that we have in the company. So, and one single activity. So we finished with the task-oriented heuristics. Now we will go to the flow-oriented heuristics. Resequencing, right? So reorder the tasks. So reordering the task in the sense that we are changing the order of the tasks according to their cost divided by effect ratio to minimize over processing. And I would like here to get a bit more of attention from you. Now, let's say we have a, let's say we have to do, let's imagine we have to do two types of check. The first, it is called a strong check. We will see an example afterwards, okay? And then we have a weak check. The question is, because we are talking about sequencing, which type of check we should put first, and which one should be put second? Yeah, the very legitimate question I expect from you here, what does it mean, a strong check, and what does it mean, a weak check, right? So, let's imagine that, yeah, after a strong check, let's say we are talking about applications, right? After a strong check, okay, this is the strong check. Huh? So let's start with 100. After a strong check, we have, let's say, 20% of the applications, they are rejected. So we get out of it 80. And then we have in the weak check, a weak check. Let's say we have 100 applications, as an example, right? An application for credit or whatever. And then out of it, we will get 98. So it is 2%. So here it is 20%. They go away. And here, in general, statistically, when we do the weak check, we have 2% that are not accepted or rejected. Question is, what type of checks you should put before? The weak check or the strong check? The strong check. So actually what we should do is that if we have two checks, one after the other, we have to do the strong check and then the weak check. So now, this is true, this is right, but what?
It's a strong check. You will get, let's say, 80, and there's less probability that after 80 questions will be rejected, and there's not much on the processing. And in the other case, when you have a recheck, you'll be proceeding with another step of production of the same units, and they will be rejected later.
Very good. So we can do it. Nice explanation. Nice explanation. This is a very good explanation using very nice words. Perfect. I will give a simpler explanation. So if we put strong check, so we start here with 100, right? Out of strong check, how much do we have that come out? We have 80. So we have to make weak checks just for 80. How many checks did we do in total? We have done 180. Right? Now, if we invert, we do the weak check, then we have the strong check. And we start with 100. So 100, and then out of the weak check, how many do we have? We have 98, meaning that in total we have 198 checks. Right? So obviously it is much better to put a strong check before, so that we are eliminating as many applications and as many inputs as possible. Yeah, please. I could not understand. Yeah. Why should it be cost? So of course we can think about theoretical um, situations where when it costs more here, if we are using perhaps a specific equipment that is expensive, of course, but here we are talking just things are the same. Yeah, they cost the same. Everything is, ceteris paribus, the same thing. So obviously it is better to put the strong check before. So yeah, strong check, they're called also knockout check. So, but we can knockout check, so it is better that we put the knockout or the strong checks before. Yeah, here we have concrete examples for this. So the make to order process. So yeah, an example of a make to order process is the kitchen. The kitchen is done in a make to order process, right? It is not done until we have the customer requirement, so it is made to order for the customer. If prepared production plan is time consuming, postpone it until after the code price has been tentatively accepted by the customer. So we are talking here about resequencing. So, for example, if the production plan is very, very expensive to do, yeah, the idea is that we're not talking about knockout checks and weak checks and strong. No, we are talking about just resequencing here. The production plan, it could be very costly to write, right? So it's basically you're starting from the bill of materials and then you are deriving the production plan. You are deriving all the equipment and machines that you require in order to make the final customized product. So the idea here, so instead of going linearly like this one after the other, prepare bill of material, prepare production plan, and then estimate cost and delivery. The idea is that why not resequencing these activities? You may tell me, okay, but in order to estimate the cost and delivery time, you need to know the production plan, or otherwise you'll not do that. But what about relying on statistical data from the past, on historical data, that when a customer comes to you with a similar product, needing a similar product that has been already produced in the past, why not trying to relate that to the product that will be made this time, and instead perhaps of providing a cost that is 100% right, you can provide an estimation of the cost and ask the customer whether the customer is okay with that price. Once you are getting more or less the approval, the customer is saying, yeah, it's okay for me. Now you can you can do the production plan. So you try to postpone that process until you get more certainty about taking the order from the perspective of the client, right? Now, the procure to pay process, if check necessity of purchase leads to 20% of knockout and check budget leads to 2%. Yeah, and here, so yeah, I will come. What is your name? Gabriele. Gabriele, so checking the necessity of the purchase or checking the budget, so more or less is, yeah, there are activities that have the same intensity. They will not be using a special equipment. So the thing is, if you put check necessity of purchase before, you will lead to a process that is easier and better to implement. So at least you will have less checks at the end than the one when you put the weak check before. Seems reasonable here, right? Have you thought about these principles before? How to, yeah, yeah. Anytime, by the way, when you think about the process, the first thing you have to do is that, yeah, what thinking about to eliminate something. Eliminate it, right? What about resequencing? So these kind of, just having these principles in mind present every time when you look at the process would be very, very, very useful. It will make innovation systematic. This is what I promised you. Remember, I told you I will give you some principles. When you apply them, you get in a systematic way innovation. Of course, you can try to look at your process and then ask people, etc. Of course, this is good also, but we would like to go into to create this innovation systematically, right? It does not mean that every time you do this, you will get an innovation, but at least it will improve your intuition with respect to the process. It will give you some practical tools in order to do this. It's much better to start from this than from nothing. Okay, parallelism enhancement. Parallelism enhancement is a very important heuristic also. Why? Because instead of having two processes going one after the other, the idea is that to ask whether you can do them in parallel, because whenever you do them in parallel, you are winning on time. You are reducing the time required for making the whole process. So very simple. And here you will have the plus gateway. Okay? So we learn when we have the plus gateway, so the adding gateway, and we have here an activity with time t1 and here t2, right? So the time required for this part of the process, it will be max of t1, t2. And it is not t1 plus t2, which is much shorter. Now, here we have some examples. Procure to pay, parallelize, approve budget, and approve necessity of purchase. So you may be able to do them simultaneously instead of having approve budget and or approve necessity of purchase. We have seen that it is a knockout check, and then approve budget. We can try to do them together if time for us is important, so that we can reduce the time. And we have make to order process here. After prepare bill of materials, we may perform prepare production plan and estimate costs in parallel. So, as I told you before, perhaps for the estimation of cost and delivery, especially at very early phases, for the code is very early phase, so you're not starting production. But you may think of parallelizing them. So you are using two types of data. So here you are using generating the production plan based on the bill of materials, and for the estimation of cost and delivery, perhaps you are using another basis of data. So the data that you can use, as I told you before, it could be similar past orders in the past. It could be used, and then in this way you can parallelize and make both activities simultaneously. Any question on this? Any? Yeah, it is almost 12, so I can understand that you're getting a bit tired. But any question? No? Okay. Okay, this is just the explanation of what we production plan estimate costs. They are done in parallel. Okay, now we will talk about process specialization and standardization. So we have talked about the task level heuristics, task level, and we talked about the flow level, right? So flow level, we have resequencing and parallelization, and now we will talk about process level. Okay. So in process level, what we can use is that we can use process specialization. We can specialize processes. So one process is split into multiple ones. For example, by customer class, by geographic location, by time period, winter or summer, and resources are split accordingly. In process standardization, two processes are integrated and resources are pulled together. An example here may make things clearer. So, specialization process. So in the procure to pay process, from procurement until payment, one process could be for direct procurement. So the first process is for raw materials, for components required really in production that go into the goods will be shipped to customers. So these are the raw materials and components required. Or we may have procure to pay, which is here, we have people that are focused on this type of materials and components. And we have people in the organization, in the procurement, that are focused on indirect procurement. And here we mean MRO, maintenance, repair, and operation. So maintenance, repair, and operation, this is a completely different types of products that are purchased by the company. So it could be components for repair, for equipment. It could be perhaps some office materials required. It could be some maintenance. I mean some oils or some fats required in production or whatever. I mean for the equipment. But they are not going into the final products shipped to the customer. So they are more facilitating our operations. We have the claims handling process. You see here the specialization, right? So you have people specialized in one category and the other group is in other category specialized. Then we have claims handling process. One claims handling process for the summer season. I mean here for insurance. And the summer season, perhaps the summer season is stormy. There are some corners of the world, perhaps it's stormy. There are a lot of rains, and this is the peak season. So where you have most of the claims with respect to car issues, car accidents or whatever. So you may have a process that is fast, process that goes much faster because you would have a lot of people claiming something. And the winter season, it is the off-peak season. So there will be less issues, and perhaps things can go slower. The checks would be much more detailed, etc. So this is one way, perhaps, how you may separate between two types of claims handlings. Then we have standardization example. You are standardizing a process. It means that you integrate claims, let's say handling for motor insurance across different brands of insurance companies. For example, you may have an insurance company with different brands. Brand 1, brand 2, brand 3, I don't know. If Allianz Insurance has under the same company, they may have many brands. And here, the claims or the claims handling, it could be integrated across different brands. Instead of having for one single brand a department that does the own claims handling, you can more or less collapse everything into one single department doing it for all brands, right? So this is a process standardization. Okay, you have also resource optimization. We finished today with resource optimization. Next time next time it will be in 2 weeks, right? Because we will have Easter next Monday, so it will be the one after, the Monday after. But we'll finish this, okay? So resource optimization. So it means very evident. Okay, we need to optimize things, use resources of a given type if they were in one room. Avoid one group of people overloaded in another similar group idle. For example, if you have 2 call centers, let's say you have 2 call centers. One call center in Milan and one call center in Torino, right? In Turin. So let's say like this. And the claims coming to the call center of Milan is much more than the claims coming into the call center of Turin. So if both call centers work separately, you may have those in Milan, the call center in Milan, more overloaded than the one in Turin. Although those in Turin, they would have capacities actually to deal with the claims coming from Milan. So if you put both call centers together, although they are placed in different cities, but they are pulled together, so it's not a big deal from where the claim is coming. Whenever the claim is coming, it will go to the one or to the individual, to the operator that is free, and then you will be here optimizing your resources better. Then let people do work where that they are good at. I think this is very simple. Yeah, sometimes, yeah, you may not find it like this in organizations. It's people telling you, yeah, we are doing things that we have never done and studied before, we have never been trained at. Could be a big issue. Yeah, when allocating work to resources, consider the flexibility in the near future. Allocate work to specialized resources first. You should keep the generalists. So you have the specialists and you have the generalists. The generalists in the company, they can do more than one type of tasks. They have more flexibility. When you have certain tasks, allocate the task to the specialist before. Keep the generalists at the end. They will give you more flexibility, right? Because if you give you are allocating the generalists before, and then you have tasks afterwards, the generalists, they are busy, that need specialists that you don't have in the pool because, the generalists are anyway away, and then you have also assigned some specialists, or the specialists that you have that can do their task already, then you will be in a trouble. So keep the generalists always at the end. Then whenever you have a task, this will give you the more flexibility for afterwards. And then this is something that is avoid setups as much as possible. We have two techniques here. It's called, one is called chaining and the other is called batching. Chain multiple tasks for the same instance, this is sequential, or batch multiple instances of the same task. I'll give you a simple example because I'm using this principle also. I'm correcting exams. You know how I'm correcting exams? So there are two ways, by the way. I will give you something that, in order to know how the business of professors in correcting exams works. You can use chaining or batching. Yeah, how does it work? The chaining works like this. Let's say we have 3 exercises in the exam, 3. And in your exam, you will have more than 3 exercises. So this is just an example, not related to our exam. Huh? Okay, very important. Don't tell me, yeah, you said in the example 3. No, this is another thing. So we have 3 exercises to correct. Exercise 1, 2, or 3. I can use the chaining principle. What does it mean? For each student, I'm correcting all the exercises together. I mean, I'm correcting 1 copy of each student every time. So, Gabriele, I correct your copy, 3 exercises, 1, 2, 3. What's the name? Federico. I correct Federico's exam, 1, 2, 3. And then I go to the next one, to the next one. This is chaining. Or I can use batch. How does it work with batching? I said to myself, okay, I will work now on exercise 1. I correct exercise 1 for everybody. Then I move to exercise 2. I correct exercise 2 for everybody. So this is batching. I'm batching the exercises. I'm batching actually the exams together with respect to one single exercise. Okay? So here, it has, of course, a certain advantage. So I'm not changing copies many times. So I have 1 copy, I finish it, and I go to the next one. I have 1 client, I complete the claim of that client and then go to the next one. But here, batching, it will reduce the context switches because, yeah, this is, yeah, correcting the first time, the first exercise will need me a bit of time. The second one I will get even faster. The third time, the same exercise, I'll get even faster, and then things will get, so I will get the context switches, the setups, they will be low here, right? Because I'm batching. Batching, we use it in production. What does it mean? It means that we're not making one component at a time. We are making a batch of components at a time. Why? To reduce the setup cost. And you know, people have also mental setups. So when I finish exercise 1, then yeah, it's finished. So I stay in the same context until I finish it. Then I go to the second context, which is exercise 2 at central. Understood how it works with batching and chaining? What do you think? What kind of principle I use? What kind of heuristic I'm using? Who says batching? Who says chaining? Only one, 2? I'm using chaining. Thank you very much. See you next week. Perhaps you have any question here? No? Okay, then not seeing you next week, seeing you the week after. So it has no influence on the grade, right? Chaining or batching, everything will lead to the same grade. Don't think about it too much, but it was, yeah, it's an example in order to clarify this. Thank you.